we'll share this with you too, so you guys can use it as a document that you because it covers everything, every aspect of Prism. So, what is a prism? Just as a basic idea, essentially, it's a triangle. It's a piece of it's a piece of glass that's cut into a triangle. It has a base, which is the thick part, and it has an apex, which is the thin part. So even whenever you look at a lens, when you look at a pair of glasses in a frame, you have a thick part maybe towards the edge or maybe towards the nasal, and then you have a thin part maybe towards the edge, maybe towards the nasal. It just depends on what type of lens it is. So a prism essentially, or a lens is essentially two prisms put together. A prism diopter, or the definition of a prism diopter, is a deviation of 1 centimeter over a distance of 1 meter. That means that light is going to bend down, first of all, towards the base, and it's going to bend down a deviation. So if this prism were not here and continued to go straight, or the light continued to propagate straight, that's where it would be. However, because the prism is in the way, it's bent down towards the base, and it's bent 1 centimeter over a distance of 1 meter. 2 meters, it would be bent over 2 centimeters, etc., etc., etc. So how does a prism affect vision? You guys have trial lens sets here, right? So you guys have the prism lens set. You can hold a prism. I think they come in 5, 10, and 15 diopters. So go and find one of those prisms and hold it up against a straight something. So let's say the edge of that table, the edge of that wall, or whatever. And what you'll notice, wherever the thick part of that prism is, the wall or the ledge will go in the opposite direction, or any image. So I could hold it up to your face, and your face would be over here if the base were over here, right? So light is going to be bent towards the base. However, the image is going to be bent towards the apex, right? And that's an LSU Tiger, just so you know, because I'm a big LSU fan. Football season starts August 31st, by the way. So there's different classifications of prism. So you've got relieving prism, adverse prism, measuring prism, and disassociated prism. So what the doctor will probably do is use a lot of these different types of prism. Why would somebody be prescribed prism, or why would we grind prism in glasses that doesn't necessarily have prism in the prescription? So again, how is a lens constructed? So we've got two prisms. A plus lens is base to base. A minus lens is apex to apex. So think about a plus lens. A plus lens is thick in the center, thin on the edges. So this right here is thick in the center, thin on the edges. And then a minus lens is thick on the edge and thin on the center. Right? And again, if you're not familiar with lenses, you have stock lenses here, right? So pull some stock lenses. You can feel how thick it is in the center for a plus, and you can feel how thin it is for the minus. Where the bases meet in the plus lens is what we consider the optical center. So the optical center is a point on a lens where light is not deviated. So if light were going to continue to go through these two bases, light would not be deviated. And then for the minus lens, where the apices meet, is the optical center. So again, light would not be deviated at that point. So anytime as you move up or down through those points, it will be deviated. So object displacement, I'm trying to read my slides. So this right here, whenever we have to deal with prism, or whenever we're looking at prism in the lab, or whenever we're checking out prism, or whenever we're trying to determine the amount of prism that a pair of glasses has, it's always a good idea. Anybody taking the ABO? Yep. Are you certified? So this is actually an ABO CE.
I let it go.
You let it go?
Okay. I had it for 40 years and I let it go.
Yeah. Well, they'll ask you a lot of these questions on the ABO, but this is actually something that comes up in your day-to-day. Some of the questions they ask on the ABO is like, never use that again. But this is actually something that you'll use. So when we take a look at our pupils, right? So these are the glasses, and then the black parts of the pupils, and then this is a lens drawn over the frame, right? So here we have our two bases are above the pupil, so this would be considered base-up prism. Right? So it's base up in the right eye, base up in the left eye, because the base, in reference to the pupil, is located up. Yep. If I move them both down, right? So now my bases are below the pupil. See that red line? See the base of the lens? The base is below the pupil. That's base down. So I have base down, base down. If I flip them over, now you can see where the base is in relation to my pupil. It's towards the nose. This is referenced as in, or in type prism, so my bases are located in, right? Now this one lens you can see is located towards the temple side, and the base is outside of the pupil. So that's base out for the right eye, still base in for the left eye. Okay? And then I can move that one out. Now what I have is base out and base out. All right? So this is Prentice's rule. It can be written in two different ways, right? So Prentice's rule is the amount of deviation in centimeters times the power in the meridian for which you're looking for. So let's say, for example, you're looking for horizontal prism. You're going to find the power in the horizontal meridian. If you're looking for vertical prism, you're going to find the prism or the power in the vertical meridian. So a prescription is constructed of a sphere and cylinder and an axis, right? Sometimes it's just spherical. Sometimes you just have one number, you don't have any cylinder. Sometimes you have cylinder, which means that the patient has astigmatism, and it's going to have an axis associated with that cylinder. So the cylinder is going to act in different ways, meaning that you could have a certain power in this meridian and a different power in this meridian, what we refer to as major meridians. This is the 0-180 meridian, this is the 90 meridian. Okay? So I say that Prentice's rule can be used in two different ways. So let's say, for example, that the PD is off 10 millimeters, all right, because we work in millimeters. That's 1 centimeter. So all we have to do is move our decimal place one place to the left. If you don't like to move your decimal place one place to the left, if that just bothers you and you hate it, then you can just divide by 10. So you can take 10 millimeters divided by 10, you're going to get 1, and that's 1 centimeter. All right? So that's kind of how it's written in different ways. I prefer this way. A lot of people prefer this way. So let's take an example. A -5 dioptric sphere was made with the PD 4 millimeters off. How much prism is induced?
Diopter each eye.
Huh?
Just diopter each eye.
Is what? 1
diopter each eye.
Yeah, well, it's just using an overall power. So a -5 is made 4 millimeters off, so we're just going to use 4 millimeters, right? Yep. Now you're getting ahead of us. So again, we can use this method here. We can divide the overall result by 10. So the amount in millimeters that it's off is 4 times 5 gives us 20. 20 divided by 10 gives us 2 diopters. So we have 2 diopters of prism in that lens, right? I hear what you're saying. So normally what we would do, if it's 4 millimeters off, that means it's 4 millimeters off because we're taking 2 eyes. So it means the total PD is off 4 millimeters. So we might say 2 millimeters for one eye, 2 millimeters for the other eye. But in this case, because the question didn't specify, it just said that lens was 4 millimeters off. So a +3 dioptric sphere was made with a PD of 2 millimeters off. How much prism is induced? So now we can do it the other way. So we can say it's made 2 millimeters off, or 0.2 centimeters. 0.2 times 3 gives us 0.6. So 0.6 diopters. Make sense? Good so far? Rock and roll? So now, what if we have cylinder? We have to determine the power in the given meridian. So if our PD is off, we need to know the power that's off here. And we also need to determine our vertical meridian to determine vertical prism. Right? A lot of tickets, so a lot of when you order our lenses, we'll give you the value on the verification ticket, what the power, the total power is in the vertical meridian, what the total power is in the horizontal meridian. I mean, vertical meridian, horizontal meridian. So when we take a look at our drawing, we've added some extra stuff. So our PD is the distance between the pupils, right? And then your made PD is going to be, oops. This is the made PD. So let's say, for example, we have a PD of 60 here, right? So the distance between the center of the pupils is 60. And then the lenses were made, you can see those were probably made at 55 because they're more narrow, because the bases of that lens are made in, right? So this is going to tell me, after I draw my lens, I know that this is base in and this is base in prism, right? So I'm going to have base in on one eye, base in on the other eye. And this is important because in some cases you can have canceling prism and you can have compounding prism. So you can determine, okay, does base in and base in, does that mean I have to add the 2 values that I get for each eye together, or do I need to subtract each eye? Everybody with me so far? Good. So now we're going to get into minus lenses, which are a little bit different. So you can see again, here's my PD, And then again, remember the optical centers of the lens are where the apices meet of the minus lens. So where my pupil is in reference to the base, can anybody tell me where my pupil is in reference to the base? What type of prism is that for the right eye?
Base
Out.
Face out? Yep.
So,
Because the base is located outward, right? It's in the triangle that it's in. Same thing here, base out, right? So if the OC is displaced up, it's going to be base up. If it's down, it's going to be base down. Relatively simple, right? So you can see here, this right eye, the base is located in the pupil, up, so it's base up. This is a minus lens. It's in this triangle here. The base is down. Now that I move it, right? So if I move the lens down, my base is down. And then I moved it down, so my base is up, right? If you are taking the EBO, if you plan on taking the EBO, that is a lot of common questions. If the patient looks down, what type of prism is there? If the patient looks up, if the glasses were moved down. So there's different effects if somebody looks down versus the glasses being moved down. Different prismatic effects. So canceling and compounding prism. Remember I told you that differing prisms for each eye can have differing effects, okay? So same direction is going to cancel, and I always use the hand method, right? It helps me to visualize it. So if I have base up in the right eye, base up in the left eye, both my hands are going up, right? That means the prism is going to cancel. If I have base down, it's going to cancel, same direction. If I have base up and base down, opposite direction. One hand's going up, one hand's going down.
yeah,
It's going to compound each other.
yeah,
So yeah, to his point, I mean, if you have one that's base up, if you have one that's base down, that's a total amount of prism. That's what we're looking for. That's the value that we're looking for. Now, if you're checking out a prescription from a doctor and the doctor has, you know, a half a base up and a half a base down, that's what you want. You want a half a base up and a half a base down, right? That's a total of one. But if it's not prescribed prism and you have a quarter up and a quarter down, you have a total of a half, right? It's going to fail. You're only allowed a third. So everybody gets the canceling and compounding. So again, up and up is going to be fine. Now there is a reasonable expectation that we don't want 5 diopters up and 5 diopters up.
right.
Cancels doesn't mean it's a good thing, right? There is no standard that says you can have 5 up and 5 up or 2 up and 2 up. There's no standard that's going to say this is the limit for equalizing prism. What we call yoked prism, actually. So yoked is a term where it means it's the same in each eye. But there's not a limit to that. So just use your better judgment. You know, probably a diopter and a half is about max. That's about what most progressives have, or a max of about a diopter and a half of what we call yoked prism. So up and up is going to cancel. Again, same thing. What kind of minus prism is this? Base down. Yep. Because the bases are located in that triangle. The base is located down. So in reference to where the pupil. So don't pay attention to that one.
Right.
It's just the triangle that it's in. Right. So the triangle it's in, base down. Okay. So now I've got base down in one eye. We've got base up in the other eye. So does that compound or cancel?
Compound.
Compounds, right?
Yeah.
You guys. Now I have base in and base in. This is kind of where it gets a little tricky. People don't like base in and base in, right? Because they think, well, it's base in, it's the same direction. Well, it's not actually, right? Because the one eye you've got in, the other eye you've got in, my hands are going in opposite directions,
Oh, yeah.
right? Opposite directions means that it compounds. So if I have 2 diopters base in, 2 diopters base in, I've got a total of 4 diopters. Good. Oops. I'm not gonna go through the whole slide. I think I missed it. Base out. Again, compounds. Out. Hands are going in opposite directions. Okay, so now I've got a right eye of -2, a left eye of +2. The PD ordered is 58. The PD made is 62. So this is in reference to what he was talking about, right? So the PD made is 62. The PD is 58. That's a binocular PD. I assume most of you guys take monocular PDs nowadays, right? Without a monocular PD, you're just going to split the difference. So I know the difference between 58 and 62 is 4, so roughly 2 per eye, okay? So 68, 2 millimeters per eye. 2 times 2 is 4. 4 divided by 10 gives me 0.4 diopters of prism. Right, that's per eye. Okay. So now let's find the direction. So I have a minus eye on the right, a minus lens on the right eye, and a plus lens on the left eye. All right. So remember that PD was made wide, so I want that optical center to be wider, right? Same thing. PD was made wide, so now they're both wide. All right. So where the PDs are in relation, this is base in, this is base out, right? So I've got the right eye has 0.4 base in, the left eye has 0.4 base out. Is it canceling or compounding? Canceling. So the net effect is 0. And that would be up to you whether you would want to send that out, whether you think that's acceptable or not. You know, I think a PD 4 millimeters off isn't acceptable, so
Yeah, that's fine.
send it back. So the right eye is plus 3, left eye is plus 4. PD ordered is 3133. The PD made is 3032. So again, the distance from here to the pupil is 31. However, the optical center to where it was made is 30. Same thing here is 33, 32. So you can see it's more narrow. So that's base in and base in, right? Yep. So the right eye, 1 times 3 divided by 10 gives me 0.3. 1 times 4 divided by 10 gives me 0.4. So I've got a total of 0.3 in the right, 0.4 in the left. What's my total amount of prism? 0.7. Yep. Passed or fail?
Pass.
0.7? Not 0.66. Fails. So this is what we were talking about, ANSI standards. This is kind of just a quick breakdown of what ANSI standard says. So you have vertical prism. If the power is plano to 3.37, you're allowed a third. If it's greater than 3.37, you're allowed 1 millimeter. That means that you're allowed 1 millimeter within the optical center, right? Horizontal prism, plano to 2.75, you're allowed 0.67. Greater than 275, the PRPs or the prism reference point or the optical center needs to be within 2.5 millimeters of each other. So that last one would have passed. So it would have failed this because it's 0.6 because it was 0.7, but it passes this here, and this is the rule we need to use because the powers were greater than 2.75.
The power is what it is.
Yep. And then, well, you sit on the ANSI committees, and then they have this long-winded argument. Well, what if one power is at one point, and what if the other power is at the other point? It's like watching paint dry sometimes when you sit in these committee meetings. Okay, so what if we have cylinder, right? If we have cylinder, then we need to worry about the power in particular meridians, mainly the vertical meridian and the horizontal meridian. So if our axis is 30 degrees, that means 25% of our cylinder is going to act in a particular meridian. So let's say, for example, our axis was 180. Our axis was 150, and we wanted to find the power at 180. That means we would multiply 25% of our cylinder and add it to our sphere, and that would be the total power in that meridian. Bear with me?
Yeah.
So 45 is 50%. 60 is 75%, and then 90 is 100%. We know 90 because we might transpose our x's back and forth, right? So if we have a -1 plus 2, we're going to add that plus 2 to the sphere, where we're going to get +1, -1, and then we're going to change our axis 90 degrees because our full cylinder acts 90 degrees away from the axis. So here's an example. Our x, what's the power at 90? So -2 -1 at 30 is 60 degrees away from 90. So 30, 60 degrees away. 60, 75%. So we're going to take 75% and multiply it by our cylinder, and we're going to get -75. We're going to add that 75 back to the sphere power, so we have a total power of 2.75 in the 90th meridian. So power at 180. So if our prescription is 135, how far is 135 away from 180? So 180 minus 135 gives us 45 degrees. We know that 45 is 50% of our cylinder. So we're taking 50% of our cylinder. Our cylinder is 150. So half of 150 is 75. Now I'm going to add that 75 back to that sphere power. So now we've got a total of -3 at 180. That should be right, not 90. So here's another way to look at it, right? This is another formula to look at, as opposed to what if you had an axis that wasn't quite 45 degrees? What if it was 48 degrees? What if you had an axis that was 29 degrees as opposed to 30 degrees? So this is the again, people don't like math, I understand that. But this is actually easier to perform on your calculator than what I just showed you, believe it or not. Yeah, everybody has a phone. Yeah, everybody has an Android device or an iPhone. If you take that iPhone and you rotate it this way, landscape mode as opposed to portrait mode, it turns into a scientific calculator. Yeah, so you can do this and you can get those values. So you can easily check that, right? So you can take the sine of an angle. So take sine 45 and square it. I mean, sine 30 and square it, and you're going to get 25% or 0.25. So what is the power at 180 if the Rx is plus 2 minus 3 at 37? Again, 37 is not an even number, so it's going to be 143 degrees, or we can say the zero. We can say 37 degrees, or we can say 147 degrees. Either way, if you take the sine of that number, the sine of 37, or the sine of 147 and square it, you're going to get the exact same thing. Okay? So you wouldn't have to even do any math here. You would just know, okay, it's 37 degrees. So again, here's your formula. If I take the sine of 143 and I square it, I get 0.36 or 36%. 0.36 is 36%. 36% of my cylinder, which is 3, added to my sphere, 1.08 added to 2, I have plus 0.92 at 180. So that's going to what that's going to tell me is if my PD is off, right? I'm not using that plus 2 number. I don't want to use that plus 2 number if my PD is off. I want to use the plus 0.92 number, which is a less number, right? Which gives me an expanded tolerance. So if you don't like math, right? Understood. There are apps, there are different web versions. There's probably more than this. Probably laboratories have other apps that will help you to calculate and understand Prism and the differences, right? So there's websites and things like that. So again, this will be in the presentation if you want to use it. So in the lens meter, lensometer, whatever you want to call it, there's different terms. You have a series of concentric circles. So you have the first concentric circle, the second. I don't know what kind of lensometer you have, but the Marcos and the B&Ls are labeled with numbers. Each concentric circle will have a number, except for the first one. The first one usually means that that's a half a diopter. The second one, 1, third, 2, fourth, 3, and then the fifth, 4. Yeah. And so that means if the reticle or those green lines on the lensometer line up at those particular reticles and you can't move them, that means you have that amount of prism. So these are Meyers. For lack of a better term, we often refer to them as the skinny ones and the fat ones, right? The skinny ones are the sphere lines and the fat ones are the cylinder lines, right? The skinny ones have a series of 3 small separated, and then the fat ones just have 3 solid lines that are 3. Where the 2 middle ones meet in the middle, that's where you want that center in the center of the reticle. So you can see here, I have a lot of lines, right? However, where the center ones are on that half adapter reticle. See how that lines up on the half adapter? Yep. So what that means is that you have a half diopter prism, okay? The direction, it's down, so you have a half adapter down, okay? If we were to move it over, this would depend on the eye that you're checking out. So it's just like you're looking at the glasses. So if my Meyers are here for the right, this is my right eye. If my Meyers are here, that's base in. If I'm looking at the left eye and my Meyers are here, it's base out. And then you have what we call compound prism, okay? And again, many of these apps will help to also describe this as well. So if I have 1.5 diopters base up and 1.5 diopters base in, do you see how that's 1? In the middle of that is a half, okay? That first circle, second circle is 1. That second circle is 2. So in between that is 1.5, and then I'm located here. So I'm 1.5 up, and I'm 1.5 in or out, depending on which eye I'm looking at. However, my total amount of prism, or my compound prism, is 2. So a lot of times you'll see on the verification ticket, that's how it'll be listed. It'll be listed that we have two diopters, and this is 45 degrees right here. If we looked at a coordinate system, so this is 45 degrees. So if we had two at 45 degrees, that really is another way of saying 1.5 up and 1.5 outer in, depending on which eye we're talking about.
Yeah, I have a sheet back there. If you have a compound prism, 1.5 in or 1.5 up, you look at it, you come across and tell you, well, it's two base, it's a 45 degrees or whatever, or 35.
Yeah, yeah. That's good that you have that, because they still have them, they still make the charts.
Yeah.
A lot of people don't use it, but it's an easier way to check out compound prism than sit there and try to locate it in the lensometer and finagle things around. And we also have on the lensometer, you'll have a dial up at the top, and it's going to list your axis. So it's going to have 0 here, 90 here, 180 here. Now it won't have the full circle. So sometimes on verification tickets you'll see at 270. Well, 270 is exactly below 90, right? 360 technically is over here. So just 360 is a full circle. So whenever you're checking workout, look for that too, and then that will be able to tell you where to place those Myers in the lensometer. So again, where the 2 points come together, and then you'll have a little line, and that little line is 45 degrees. More math, right? So if we wanted to do the math route as opposed to using the app, right? Because we don't want to use the app and get out the easy way, or we don't want to use the chart that you have, right?
Yeah.
So we want to go ahead and really sit down and figure it out on paper, right? Because we're all excited to do that. So everybody had heard of Oscar had a hold on Alice, or Apple, or I used to say Alice, but I don't know if that's politically correct anymore, so you can't really hold Alice anymore, so I changed it to Apple. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we have our angle here. This is my opposite side, this is my adjacent side, so my adjacent side is touching the angle, and my longest side of a right triangle is your hypotenuse. So if I'm looking for the vertical component, I'm going to take the sine of the angle multiplied by the hypotenuse, or the prism amount, and that's going to give me my opposite side. Horizontal is going to take the cosine of that angle times the hypotenuse is going to give me the adjacent angle, or the horizontal meridian. So adjacent is going to be horizontal, opposite's going to be vertical. And we're not going to go through the math. I can see your faces starting to get like, oh my God.
Yeah, that's tough.
So anyway, you're going to have right here with two diopters at 45, you're going to have 1.41 and 1.41, so horizontal and vertical. And then again, you can see it kind of worked out here for the total amount. If you have 2.5 diopters base up, 1.5 diopters base in, we're going to take the square root of both of those sides. Squared, we're going to get a total of 2.92, right? It's going to tell me what meridian it's going to be in at 59 degrees. So again, this gives me the nasal, tells me where it's going to be located in the lensometer.